Hello, welcome back. So today's lesson is tied to what we've been doing area, but it's going to be area that's better shaded in horizontally instead of vertically. And this first video is going to kind of compare one problem doing it how we learned to do it in the past videos in terms of X, and then we'll do the exact same problem but in terms of Y, which will be horizontal, and kind of compare the difference and how do you know which one you should pick. So if we look at this problem, it says, this is, by the way, page 5, that should be the next thing in your notes. It says, find the area of the region by integrating first with respect to x, which is what we've done so far, and then we're going to do with respect to y, which we'll talk about, and then we're going to compare the results and decide which one would be more simple, and is this always true or just for this problem, and how do you know? Okay, so what's nice about this one is that they went ahead and give you the graph so you don't have to come up with your own. So we have notice now it's x equals, okay, so that should ring a bell that this is kind of different because normally it's in terms of y equals and then some function in terms of x, but now it's x equals some function in terms of y. So if we're going to do it the way we've done it in the past, we're going to have to get y alone. We're not going to do that quite yet, but so this x equals y minus 4 minus y squared is going to be this horizontal quadratic, and this x equals y minus 2 is going to be this linear line. So for part A, we're trying to find the area with respect to x, which is how we've done so far. So if you think about when you're doing with respect to x, I don't know if you noticed, but when we wrote on that front page, we said it's vertical. So what I should have probably went more in detail, but what that means is because when we shade this in, we're going to draw vertical lines to shade it. So to do that, well, first of all, you should notice the top function changes, right? So we need to get these, but before we go set up our integral, we need to get these the intersection points and endpoints so we know where are we starting our area, what is this value, and where are we ending our area. So we know our A and our B, right? Because this would be our A, this would be our B. Our A is the farthest left the area goes, and our B is the farthest right. So how do we know? Because A is where they intersect. So we're going to set these equal. So notice, you're going to take 4 minus, I'm going to come up here and do it so I can set up my integral down here. 4 minus y squared and set it equal to y minus 2. Notice it's in terms of y, but that's okay. We'll just get what y they share, and then you can solve it for the x. I wouldn't go ahead and solve these and then try to set it in terms of x equal because it's going to be more difficult, and I'll show you why in a second. So if we go ahead and solve this, we notice we have a square term and a non-square term, so factoring should come to mind, so we need to move everything to one side. So because I want my y squared to be positive, I'm going to move everything to the right side. So I'm going to do plus y squared. So we have 4 equals y squared plus y minus 2. And then I'm going to move over my 4, minus 4. So we have 0 equals y squared plus y minus 6. Now we factor, so it multiplies to get negative 6. And, oops, what am I writing? And adds to get positive 1. And that would be what? Positive 3 and negative 2. And check it in your head that that foils correctly, and it does. So that makes the intersection points at negative 3 and positive 2. So notice that is y. So that means this point right here, the y value is negative 3, and this point right here where they intersect, the y value is positive 2. That is not your A value because your A is in terms of x. So how do we get the x value? Just like before, if we want the actual ordered pair, you plug these back into either equation. You can pick which one's more simple. So I would pick the bottom one. So when I plug negative 3 back in for y, what does that make x? X equals negative 3 minus 2. I was about to put plus. Negative 3 minus 2 is negative 5. So that that ordered pair that they intersect is negative 5, negative 3. So that makes this A value negative 5. And then do the same thing to find B. Oh, wait. Let's think about this, because that's not y equals 2. that would give you this intersection point. So if you plug in 2, x, use that same equation, 2 minus 2, which you should have been able to look at the graph and see that that's going to be 0. That order pair is, why did I write there? I'm making all types of mistakes. X equals 0. So the order pair is 0, 2. And you should have known that because that's on the y-axis. But notice that's not your A or B. Now that is going to matter in a second. But our B value is this vertex of our horizontal quadratic, which is going to be actually 4. You can look at the tick marks and see it goes by 2, 4, 6. Or it's going to be because of this 4. It was a horizontal quadratic shifted over 4. Okay, so now we know our A is -5, our B is 4. So when we go set up our integral, we do top to bottom, right? So really think as you draw these vertical lines. Here, my top is this linear line, y minus 2. And my bottom is this quadratic. Okay, so then that's true here, true here, true here. Now it switches, right? But look over here. On this right side of the area, our top is the quadratic and our bottom is also the quadratic. So that's kind of weird. How do you do top minus bottom when it's the same function? Because you would think that would be 0. So why is this acting so weird is because remember when we go integrate it needs to be in terms of x, right? When we do vertical lines it should be all in terms of x dx. So we need to go solve these to get it as y equals, and then it might start to make more sense. So if you notice, this is kind of a lot of work, so hopefully it's leaning to something that's going to make it easier. So when I solve this for y, what I would do is move over the y squared so it's no longer negative, and then move over the x to the right side. So if you do plus y squared, and you have y squared plus x equals 4. And then you move over the x, so you have y squared equals 4 minus x. And then how do we get y alone is we're going to square root it, correct? So when you square root each side, you're left with y alone over here. Now don't forget, we forget this a lot. When we square root, technically it's always plus or minus the square root of 4 minus x. Okay, so that's why it's not a, this horizontal quadratic isn't a function, right? If you, the vertical line test, it would fail because this top half is a positive square root and the bottom half is a negative square root. So it's almost like two different functions. So if I was going to label this graph, it's like this top half of my quadratic is 4 minus the square root of 4 minus x, and the bottom half of the quadratic is the negative version of square root of 4 minus x. So when I come over here and do top minus bottom, it's positive square root of 4 minus x for the top, and negative square root of 4 minus x is the bottom. So that becomes almost two different functions. And then we can get our linear line in terms of y equals as well, which is easy. You just do plus 2, right? And you have y alone. So that would become y equals x plus 2. So I'm going to write that right here. So notice, and you could even write these as y equals, y equals. So now we got all of our functions in terms of x. Okay, so now I think we have everything we need to set up our integral. So the first thing we think of, remember when we go top minus bottom, we're going to have to break up this integral, this area into two different integrals because it switches. So we're going to first focus on this left side integral. So I'm going to write the integral. You know what, I'm going to come down a little bit because I don't want to run out of room. I'm going to put part A down here. And I have the integral from the farthest left you start at is -5. And then where is it going to switch? Where is the top function going to switch? Right here at this intersection point. So we're going to do from -5 to, what is this x value? Which is 0. And we're going to do top function, which is this linear line, so x plus 2, minus the bottom function, which is this bottom half of the quadratic, which we said is negative So I'm going to put that in parentheses. Square root of 4 minus x dx. Okay, so that is this section. And now once you get past x equals 0, now the top changes. So we're going to add a second integral that starts at 0 and goes to what x value? 4. And now when you draw these vertical lines, it starts at positive square root of 4 minus x, and then you subtract the bottom function that it goes to is still this negative square root of 4 minus x. So it's kind of weird. This second part doesn't use that linear line at all. You have to really draw those vertical lines and think top to bottom. Okay, so that is very messy. If we were going to integrate this by hand, you'd have to really break this up, because what would you need to integrate this? If you have something inside of something else, you would need chain rule. Now you could clean this up and change this to plus if you want, change this to plus, but we are not going to work that out. Now I have it typed in a calculator, but I'm going to wait to show you. Let's see if we can set up an easier integral using this new method. But theoretically, this should get you the right area if you were to work it out. Okay, so why was that kind of weird? Because when you did top to bottom, the function switched. So now let's think, could I shade in this area going horizontally? So instead of going top to bottom, could I shade this in going right to left, and draw horizontal lines? Notice when you shade it in going horizontally, is it staying consistent right to left? Are you starting at the same function and ending at the same function for the whole area? Right? No matter where you draw a horizontal line, you should start at the quadratic and go to the linear line. Start at the quadratic, go to the linear line as you shade in this whole thing, so we're not going to have to break it up anymore. So when you go horizontally, now instead of going top minus bottom, you're going to go right minus left. So before we do this, finish this example, go back to that first page. You need to pause the video, and we're going to write a formula. So if you're going horizontal, then your area is now going to be the integral, and now instead of x, it's all going to be in terms of y. So it's going to be y1 to y2, and instead of top curve, it's going to be right curve minus left curve. And now it's going to be in terms of y. These functions are not going to be in terms of x, they got to be in terms of y, so it's going to be dy. If you're going horizontal, maybe we should write that. It needs to be in terms of y. So what does that mean? Is your functions need to be x equals something in terms of y. If it's vertical, it's in terms of x, which means your function needs to be y equals and then some function in terms of x. Which is why this original, so now we're going to use this formula. These original functions were in terms of y, they were x equals. So we're not going to have to use this solved for equation. We can use the original formulas if we're going to do horizontal, which is what it really wanted you to do in the first place, but I'm trying to show you the connection between the two. So let's see if we can set this up. It would be the integral. Now your boundaries are no longer going your x values, because think about when you shade in horizontal lines, you're starting at the bottom, so we want that bottom y value, and then you're shading horizontal lines until you get to that top y value. So your boundaries are your y values. So it would be down here would be your a, and up here would be your b. So if you notice, that were these values we got when we solved for the intersection points, right? When I draw a horizontal line, the lowest horizontal line I draw is at y equals -3, so that is my a. And if I keep drawing horizontal lines till I shade the whole area, I get up to y equals 2, which is my b. So that you still use your intersection points, but now they're in terms of y, which is good because your integral is in terms of y. Just like before, we got our intersection points by setting them equal, but they were in terms of x, and they were your boundaries. Now you get it, and they're in terms of y, and they're still your boundaries. And when now I got to think right minus left. So when I draw a horizontal line, my right, no matter what, it's this quadratic, but you don't have to break it up anymore. It's just what it is in terms of x, or in terms of y. So it's 4 minus y squared is the right curve. And then minus the left curve, when you draw these horizontal lines, was the linear line, which in terms of y was y minus 2. So when you have a horizontal quadratic, if you integrate in terms of y, you don't have to break it up as the two different functions. You only have to do that if you're going to make it in terms of x, which you shouldn't really do. And now this is all in terms of y, so it's dy. And now we could clean this up, and this is going to be a lot easier to integrate than this function, right? So what I suggest is, I don't want to make this video too long. Let me clean this up with you, and then I would pause the video and try to integrate it on your own, and I'm going to give you the answer and see if you can have the right answer. So if we were to clean this up to integrate, I would distribute this negative sign, right? So I don't really need the parentheses on this first part. Then that becomes minus y plus 2, and then I would combine my 4 and my 2. So that's negative y squared minus y plus 6. And then you could integrate that on your own. So pause the video here. See if you can integrate that and do f of b minus f of a. Pause it before I say the answer. And the answer, if you did it by hand, you should have got 125 over 6. Or if you get that as a decimal, that is approximately 20.833. So would this original vertical in terms of x integral equal the same thing once we add them together? Well, here you go. I typed it in already. And you can see it is also 20.833, or 125 over 6. So let me go ahead and we can say that that also equals 20.833. So it's the same thing. They're both giving us the area of that shaded region. It's just which one's easier, right? So question C we'll just talk about. You can write it down if you want, but the results are the same. Why would this second version be easier? Well, it's because if you draw those horizontal lines, it stays consistent right to left the whole time. If you go down top to bottom, it's going to switch what is the top and what's the bottom. So if it doesn't switch, it probably would have been easier. But also, anytime they give you the original function and it's already x equals instead of y equals, they probably want you to do it in terms of y, which would be horizontal. Okay, so pause that, kind of think about it, make sure the process of why you would pick which one makes sense. And as we do more examples, hopefully it starts to really click, but really think about when you shade in that area, is it easier to draw vertical lines, which would be in terms of x, or horizontal lines in terms of y? We will do more examples in terms of y on the next video.